Hello everyone. In this video, we look at again some of the topics that you can expect in the logical reasoning section of the general test of the CUET exam. Right? The topics that we look at very briefly are cubes, ranking, basic concepts of clocks, inequality and visual reasoning, and data sufficiency. All of these are topics that you will keep seeing in a lot of previous exams like CU, CET, etc. at the school level or otherwise, wherever logical reasoning has been asked. To start with, cubes, right? As far as cubes is concerned, there are three broad types of questions. When a larger cube is cut into smaller cubes, when you open the cube in 2 dimension, and the adjacent faces based question. Looking at them one by one, what happens when you cut a larger cube? Now, a cube is a solid object with all sides being equal. So, let's just try and draw a cube. Knowing my drawing, I'm sure I'll mess up, but what's the harm in trying? Looks something like this. Something, right? So, my drawing, my handwriting is only the only thing that can beat my handwriting is my drawing. It's even worse. So this is a cube that I have. Now suppose I tell you that I've painted this cube black on all faces. Alright. Now it is also given to me that the side of the cube says 5 centimeters. What we do is we cut this cube into smaller parts of 1 centimeter each. Right. So the first question is, how many times do I need to cut the cube? Now, if there is a rope and you have to cut it into 2 parts, you have to cut once in between. So one cut produces 2 parts. What if I cut the rope at 2 ends? I will get 3 parts. If I cut the rope at 3 points, I will get 4 parts. So if the side of the larger cube is 5 centimeters and you want small pieces of 1 centimeter, that means you need 5 parts. So you need 4 cuts. Alright. And since the smaller parts that I want are also cubed, I will have to cut in the vertical, in all 3 dimensions essentially, along the length, height and breadth. So I make 4 cuts like this. They will look something like so. So I kind of get these slabs. Then I cut across the horizontal. So these kind of rods is what I get. And then I cut these rods as well. So I cut along this length 1, 2, 3, 4, which will extend till the bottom. This is one cut, this is one sort of cut, this is one sort of cut. So what I now have are smaller cubes. The first question was, how many cuts are required? There are 4 cuts because the length of the cube was 5, and in each dimension, length, breadth, height, and therefore the total number of cuts required is 12. Alright. The next is, how many smaller cubes will be formed? As you can count, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this grid has 5 into 5, 25 smaller cubes, and there are 5 such grids. 1, 2, 3, 4, 5. The smaller number of cubes will be 5 into 5 into 5. 125 smaller cubes will be formed. You can also look at it by saying the volume of the larger cube is 5 into 5 into 5. That of the smaller cube is 1 into 1 into 1. And therefore, the number of cubes will be 125 upon 1, which will come out to 125. Now, the smaller cubes that you get will not have color on all the faces. For example, when I cut the cube from between, the new faces that I get on the sides will not have color because I have just colored on the outside, right? So, what is the maximum faces that can be covered in a smaller cube? जो छोटा cube होगा उसमें maximum कितने face पे color हो सकता है? देखो, there are some cubes which are here. on this one, these two faces will be colored. Then there is a cube which is at this position. Here only this face will be colored. Then there is a cube which is on the corner. Here there will be three faces colored, right? And then there will be some cubes which will be inside this the outer covering, so to say. Those cubes will have no face covered. Now what happens for a cube is a cube will have faces, edges and corners. Faces are this part, the flat part. Edge is this line where these two faces meet, and the corner is this point where three faces are meeting, or this point where three faces are meeting. How many faces for a cube? 4 in the side, 1 in front, 1 back. So every cube will have 6 faces. How many edges? 4 on the front, 4 on the back, and 4 connecting edges. Therefore 12 edges. How many corners? 1, 2, 3, 4 in the front, 1, 2, 3, 4 in the back. Therefore 8 corners. Now a smaller cube which has 3 faces colored, that is the maximum possible, will be on the edges. Because there are 8 edges, therefore the answer simply becomes 8. If I look at smaller cubes with 2 faces colored, they are the ones on the edge. Now on the edge there are 1, 2, 3, 4, 5 cubes, smaller cubes, but these 2 will be cancelled because they already have 3 faces colored. So the remaining are 3, and there will be 3 such cubes on each of the edge. Therefore a total of 3 into 12 or 36. How many cubes will have 1 face colored? So the ones on the face will be the ones which have 1 face colored. As you can see, there are 3 into 3. So basically there were 5, I removed the top and the bottom. There were 5, I removed the 2 from the sides. So 3 by 3 grid is left. This will happen on all the faces. Therefore 3 into 3 into 6. 3 into 3 on each face, 6 faces are there. 0 faces colored. The first thing that comes to mind is just subtract all the numbers from the total number of cubes. But what if that is the only question which shows? Obviously not waste time finding everything out. So what I do is I basically unbox the cube, right? So I just remove the outer layers. Okay. Now the height is 5. I take out all the top ones and the bottom ones. So the height of 3 will remain. The breadth is 5. I take out all the ones from this side and that side. So breadth of 3 will remain. Similarly, the length is 5. I remove all the ones from the front and the back. So a length of 3 will remain. If I remove all the outer parts, what I have will still be a cube. And the side of that cube will be 3. Because 2 parts have been removed from each side. And therefore 0 faces will simply be 3 into 3 into 3. To generalize this, if the side of the larger cube is n, the number of cuts simply is 3 into n minus 1. And the number of smaller cubes is n into n or n cube. The number of cubes with 3 faces colored remains 8. 2 faces colored remains n minus 2 into 12, n minus 2 on each edge. 1 face colored is n minus 2 into n minus 2. Into 6 on each face, and 0 faces colored is simply n minus 2 cube. If you do come across this question, just put the value of n as the side of the larger cube and you can solve the question, right? Actually what is n is? N is the ratio of the side of the larger to the smaller cube. So for example, if the larger cube is of side 8 centimeter and you are cutting it into smaller cubes of 2 centimeter, then the value of n will be 8 upon 2, 4. Here it is 5 upon 1, 5. The other variation that happens is you're not coloring the cube with the same color on all sides. Suppose if I say opposite faces, this one and the one at the back are colored blue, this one and the one at the side are colored red, and the top and the bottom are colored yellow. And then you are asked about different colors. Just remember one thing, the ones on the corners will have three faces colored. You can just draw and see which side has which color. The one on the edges will have two faces colored, and the one on the face will have one face colored. Everything else will have nothing, will have no color on it, right? So this is the first kind of question in cubes, very commonly asked. The second question talks about opening a cube in 2 dimension, or actually any arrangement which looks something like this. So if you open a cube in 2 dimension, for example, the closest I can think of is you get an Amazon delivery and you open the box completely. Should look something like this. So it will be 6 squares. If I fold this, I will get a cube, right? The arrangements could be different. Then even if I fold this, I will get a cube. You make this stand, cover this part and roll the other part, you will still get a cube. So 9, 10 such arrangements are possible, but typically there will be 6 squares that you will get, right? Now the question will ask you, suppose there are numbers written on each face. I fold this to make a cube. Which arrangement is possible? And there will be questions given. Always remember here, for every face of the cube there are 4 adjacent faces and 1 opposite face, right? The top will have the bottom one as opposite, the rest 4 will be adjacent to these 2. Opposite faces are never visible at the same time, right? And in any arrangement, if there are 3 squares adjacent, then the first and the third will be opposite. The fifth, again these 3 are adjacent, so 5 and 6 will be opposites. These 3 are adjacent, therefore 2 and 4 will be opposites. So in any arrangement of the cube, 2 and 4 will not be simultaneously visible, 1 and 3 will not be simultaneously visible, and 5 and 6 will not be simultaneously visible. For example, if I fold this, I cannot get this cube because 5 and 6 are simultaneously visible, right? The next is when you have to find the cube, the number on the cube. For example, if I say there is a cube with which you are playing Ludo, there are 6 faces numbered 1 to 6, okay? If I say that the cube looks something like this, these are 2 orientations of the cube. Which number is opposite which number in this cube? 1 and 6, 2 and 5, 3 and 4 does not have to happen. That happened with only the dice that we got with Milo free, but yeah. Ji. The first thing that you will check is, if you know the adjacent numbers of any face, you will know what is opposite. For example, 1 is adjacent to, 1 is adjacent 3, 1 is adjacent 5, 1 is adjacent 6. So the 4 adjacent faces for 1 are 2, 3, 5, 6. So what will be opposite 1? Has to be the remaining number, that is 4. Which number will be opposite 2? So what you do is you come from this orientation to this orientation. Now this 1 I have to bring on the front side. So what I will do is I will make it roll over. Right? So because of that, what will happen is 2 will remain as it is. If I make this fall over, 1 will come here, 3 will go down, 2 will remain as it is. But if I now compare these two, 1 is there in the right position, 2 and 3 are not visible here. So 2 and 3 would be on the faces that are at the bottom and towards the right. If I revolve this cube in the clockwise direction, then 2 comes up, 3 comes to the left, 2 and 3 will become visible. So that is not what I want. So what I'll do is I'll roll this cube in the anti-clockwise direction. The moment you do that, 2 from the left will go down, 3 from the down will go towards the right. And therefore 1 is opposite 4, 5 is opposite 2, 6 is opposite 3 on this dice. These are the questions that you can look at. If you talk of cubes also, the larger cube being cut is a more common question, and this could be part of visual reasoning in terms of LR. Just look at question set based on this. Yes. Just covered this, all you have to do is put in the answers. A cube with side 6 centimeters is painted black on all faces and cut into smaller cubes of side 1. So the value of n becomes 6 by 1. Answer the question based on this. How many cuts are required to get all the smaller cubes? Because the side is 6, therefore 5 cuts are required. 5 in each dimension, therefore 3 5s are 15. 3 into n minus 1. How many smaller cubes will be formed? Because the initial side is 6, therefore 6 into 6 into 6, 216. Just put the values in the formula that I listed. How many smaller cubes will have no faces painted? So the ones on the inside, therefore 6 minus 2 into 6 minus 2 into 6 minus 2, that will be 64. How many smaller cubes will have exactly one face painted? Exactly one face painted are the ones on the faces. On each face, I will have 6 minus 2 into 6 minus 2. This becomes 16, 4 into 4. And there are 6 such faces. So the total becomes 96. It was already answered for you. Last. How many smaller cubes will have at least 2 faces painted? Till now we were talking about exactly 3 faces, exactly 2 faces, exactly 1 face, no face painted. When I say at least 2, that means the faces which have exactly 2 faces painted will be counted, and the ones which have exactly 3 faces will also be counted. Because I am looking at the cubes which are 2 or more, at least 2, right? Now how many faces will have, how many cubes will have 3 faces painted? This number remains 8. How many will have 2 faces painted? 2 faces painted are on the edge. There are 12 edges, and on each edge in this case there will be 6 minus 2, 4 cubes which are there. Therefore 48 cubes will have exactly 2 faces painted, 8 will have 3 faces painted, therefore 56 cubes will have at least 2 faces painted, right? Then is ranking. Ranking again plays out in 2 ways. One, there could be a linear arrangement. We had done a circular ranking question in one of the previous videos in circular arrangement, or you could have game based rankings, right? One example of it could be this question. In a line, A is standing 12th from the front and 13th from the end. How many students are there in the line? The best idea is to draw the line and see. So if A is 12th from the front end, that means how many people will be standing before A? A is 12th from the front. So if I am 12th, there have to be 11 people in front of me. Then comes A. And A is 13th from the end. So how many people will be there after A? If A is 13th from the end, there have to be 12 people here. So how many people in the line? 11 in front plus 1A plus 12 behind A. So total of 11 plus 1 plus 12, which becomes 24. Straightforward question, not too much of logic involved. Now look at this question and answer. A and B are standing in a line such that A is 7th from the start and B is 9th from the end. There are 2 people between A and B. How many people are there in the line? If your answer is 18, it is wrong. If it is 12, even that is wrong. And therefore, if you think the answer is 15, you are even more wrong. What's the problem in this case? The problem is we do not know who is in front, A or B. So there are 2 cases possible here. One where A is in front of B. There are 2 people between A and B. How many people in front of A? A is 7th from the start, therefore 6 people and then A. And how many people after B? B is 9th from the end. So 8 people after B, and one of the 9th person is B. So the number of people becomes 6 plus 1 7 plus 2 9 plus 1 10 plus 8 18. But it does not say that A is in front. I could also have a case which looks something like this. B is in front. Now how many people are there in front of A? Because A is 7th from the front, there will be 6 people in front of A. Then comes A. How many people will be there after A? I do not know that, but what I know is that there are 8 people who stand after B, out of which these are 3. 8 minus 3 is 5. And therefore 6 people before A, then A, and then 5 more people. 5 plus 1, 6 plus 2, 8. Therefore, B is 9th from the end. So, in this case, the total number of people would be 12. Because there are 2 separate answers possible, the answer becomes cannot be determined. Do not make assumptions while you are solving a logical reasoning problem. Be open to every sort of case that is possible. Front, back, and between. So, front and back give you clearer ideas. Between could be anything, right? Again, ranking in terms of position. In a class of 60, Rahul was ranked 10th. If Rahul is ranked 10th, there will be 9 people in front of Rahul. If there are 6 girls ranked less than Rahul, so less than mean before 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the number of boys and girls is equal in the class, then how many boys are ranked after Rahul? So let us draw Rahul first. There are 9 people in front of Rahul, and therefore Rahul is 10th. How many boys and girls in the class? Out of 60, there are 30 boys and 30 girls. Now let's distribute the girls. There are 6 girls ranked less than Rahul. So out of these 9, there are 6 girls. How many boys will be there therefore? If out of 9 there are 6 girls, the remaining 3 have to be boys. And we know that there are 30 boys. So how many boys after Rahul? Not 27. That is the first thing that comes to mind, 30 minus 3. But Rahul also happens to be a boy. That should have been written in the class, in the question. It does not really specify, but assuming that he is a boy. 3 boys in front of Rahul, 1 is Rahul, and therefore the number after Rahul will be 30 minus 3 minus 1, which is 26. So how many boys are ranked after Rahul? Again, here the unsaid assumption is that Rahul is a boy. Ideally should not have been taken. If it says none of these, the answer would be none of these, or cannot be determined, right? Perfect. Rank sports wise or games wise, I'll just touch upon 2 broad aspects where we actually count the number of games rather than ranking them, because I think that is not something that you would expect in the CUET paper. The 2 common formats of a tournament could be league format or a knockout format, right? So league is something like the IPL that happened, the first part of it, where each team would play the other teams. A knockout format is something that happens probably in, say, Wimbledon. 2 people play a match, 1 is knocked out, the other one advances to the second round. So question 9 says in the IPL, 8 teams play such that each team plays against every other team once in every round. Total 2 rounds are played. How many matches are played in the tournament in the 2 rounds? Any answer? So whenever one team plays the other teams once, this could also be looked at in a way where I say 2 people shake hands. If there are 5 people in a room and everybody has to shake hands with the other person, how many handshakes will happen? Right? So now each person will end up doing 4 handshakes, because typically you will not go and shake your own hand. So if there are 5 people in a room, each one will shake hands with the other 4. So if say the 5 people are standing in a line, I am the first one, I will shake hands with the next 4. The next person, our handshake is already counted, so he will shake hands with the next 3. The third person will shake hands with the next 2, and so on, right? Even in this case, if there are 8 teams, team number 1 will play with 7 other teams in round 1. Team number 2 will end up playing with 6 teams because the match between 1 and 2 has already been counted, and so on, right? Where the 7th team will play with the 8th team, and the 8th team, all the matches of the 8th team have been counted. So the number of matches will be 0 plus 1 plus 2 plus 3 plus 4 plus 6 up to 7. I think a better way of looking at it is, see, each team ends up playing 7 matches. So what is the total number of matches played? 8 into 7. But the problem is every match has been counted twice. The match between 1 and 2 is here as well as here. The match between 2 and 3 has been counted in both places. So I divide this by 2. So if there are n teams playing with all the other teams once, there are n people shaking hands, amongst themselves once, the number of handshakes simply is n into n minus 1 by 2. In this case, round 1 will have 28 matches because there are 2 such rounds. The total number of matches becomes 28 into 2, which is 56. You can also say that in each round, NC2 permutation combination number of matches happen. What happens in a knockout? So in a knockout tournament, there are 128 players. They are playing such that there is a match between 2 players at a time, and the person who loses is eliminated. The process goes on until the winner remains. How many matches are played in the tournament? So if there are 128 players, what will happen is, in round 1, how many matches are required? 2 players per match. 64 matches will happen, right? 64 people will get eliminated, 64 will move on. In round 2, 32 matches will be required. 2 matches, 2 players per match. 32 will be eliminated, 32 will go on. Round 3, there will be 16 matches for these 32 people. 16 will be eliminated, 16 will go on. This process will keep on happening until you reach the final round, where there will be one game. One will be knocked out and the winner will remain. So the number of matches will be 1 plus 2 plus 4 plus 8 plus 16 plus 32, 64. The number of matches becomes half. If you add all of this, what is the value that you get? 64 plus 16 is 80. 32 plus 8 is 40, so 120 plus 4 plus 2 plus 1 is 7. Therefore 127, which happens to be 1 less than 128. So in a knockout tournament, if there are n teams, the number of matches required simply is n minus 1. The logic is very simple. Every match, one person will be eliminated. If there are 128 people to start with, you have to eliminate 127 people and then one will remain. And therefore, the number of matches required is 127. So if n players are there in a knockout tournament, n minus 1 matches happen. This concept can be taken further to find out who plays with the other person, but again, as far as the CUET exam is concerned, and since the thing already says that the syllabus will be till class 10 basic logical reasoning, I do not see it going to that level. This should be good enough for our purpose, right? Next, clocks. All of us know the clock. Questions in clocks pertain to the analog clock, right, which has 2 hands and the second hand is the 3 hands actually, but we're talking about the minute hand and the hour hand. A lot of these concepts will be parallel to the concepts in time, speed, distance, circular motion and things like that, and the only difference being, when we're talking of people running or moving, their speeds are in kilometers per hour, meters per second. In case of a clock, it does not matter whether the clock is small or large. The rate at which the hands move is the same, and therefore instead of distance we talk of angular distance. How many degrees does the hand cover in a given amount of time, right? So typically the speed of the minute hand and the hour hand we'll measure in degrees per minute, so to say, right? For example, what is the speed of the minute hand in degrees per minute? So first of all, let us look at the face of the clock. Assume that this is actually a clock. It doesn't look like one, but yeah. Something like this. What will be the angular distance between any two divisions of a clock? So what I'm saying is, at the center, what angle will be formed? Because a circle is 360 degrees and there are 12 divisions here, each division will be of angle 360 upon 12, that is 30 degrees, right? So what will be the speed of the minute hand? The unit that we want is degrees per minute. Now in an hour, what does the minute hand do? Say from 1 o'clock to 2 o'clock, the minute hand will complete one full circle, right? So the minute hand covers 360 degrees in 60 minutes, and therefore the speed becomes 6 degree per minute. What is the speed of the hour hand? The speed of the hour hand is, again, from 1 o'clock to say 2 o'clock. 1 o'clock the hour hand will be here, 2 o'clock it will reach 2. So the distance that it has covered is 30 degrees, and for that it takes 60 minutes. Therefore, half a degree per minute. All right. These numbers could be remembered, but again, they're not numbers that cannot be reproduced in the exam. You just have to remember the face of the clock and see the distance covered, angular distance covered in 1 hour. You'll get the two speeds. And therefore, see, what happens is, because the hour hand is chased by the minute hand, I can talk about the relative speed between the two hands. So if there is the hour hand, there is the minute hand. Every minute, the hour hand will cover 6 degrees, where the minute hand will just move half. So relatively, the hour hand covers 6 minus half, or 11 by 2 degrees per minute extra. Again, this is direct reference to the concept of relative speed in TSD, right? What are the types of questions? 5 types of questions you can look at: angles between hands, change of angle, number of time an angle is formed in a given time, water image, mirror image, and faulty clocks. As far as the CUET exam is concerned, I think angle between hands, number of times an angle is formed, mirror image, water image would be the more relevant question types. Change of angle and faulty clocks probably are a little bit of a stretch, but yeah, just quickly we'll just try to touch upon them. Angle between the hands. So we're looking at the minute hand and the hour hand. For example, if I say, what will be the angle between the minute hand and the hour hand at say 8:20? So 8:20, the minute hand will be at 4. The hour hand will be somewhere between 8 and 9. We want this angle. Now the thing is, the moment the time crosses 8, the hour hand moves from 8 towards 9, right? So if I just had to cover this distance, I could have found it out without any problem, because each of the division will be 30 degrees. So 1, 2, 3, 4. 4 divisions, a total of 30 degree, will give me 120 degree. But the problem is, there is some distance covered here as well. How much distance does the hour hand cover? I use the speed of the hour hand, because at 8 o'clock the hour hand was exactly at 8. In the next 20 minutes it will cover how much distance? Time into speed, something that we calculated in the previous slide, therefore 10 degrees. So this entire angle will be 120 plus 10, or 130 degrees. logically speaking. Right? What will be the angle at say 540? The minute hand is now at 8. The hour hand is between 5 and 6 somewhere. Any answers for this? So here what happens is, see, from 8 to 5 I look at the total divisions. So 30, 30, 30 is a total of 90, right? But the hour hand is not at 5, it has moved forward. So in this case I will subtract 40 minutes, half degree per minute, which comes out to 70 degrees. If you are going from the minute hand to the hour hand in the clockwise direction, you will add. I added here. If you are going from the minute hand to the hour hand in the anti-clockwise direction, you will subtract. What to add or subtract? The number of minutes into half, that is to be added or subtracted, and to what value? The two numbers that are given in time. 820 means 8 and 4, 540 means 5 and 8. So just take that difference, multiply it by 30. So 5 and 8, a difference of 3, 330 is a 90. Anti-clockwise minus 40 into half gives me a 70. The intent of telling you this is so that you don't have to remember this, and you're able to do it by yourself in the exam. Or you can use a formula directly, which is mod of 30h minus 11 by 2 m, where h is the hours, m is the minute. So if I put the value of 820, I'll get 30 into 8 minus 11 by 2 into 20 mod. So 240 minus 110, which is 130. Here it will become 30h minus 11 by 2 into 40. So mod 150 minus 220 mod, that is mod of minus 70. Mod means you just have to remove the negative sign. For anyone who does not know, that is what we will know mod as. You can get the answer. So either you can use that formula directly or do it by yourself. The second question talks about change of angles. So typically the question will say, when do the hour hand and the minute hand overlap or meet or make an angle of 0 degree for the first time after 3 o'clock, right? So at 3, this is how it looks. Somewhere after 3 they will meet, and then the minute hand will go forward, right? So here we use the concept of relative speed. What we do is we look at the starting angle. So at 3 o'clock it is 90 degree, and we look at the final angle, it has to become 0. So when will the minute hand and the hour hand meet after 3 o'clock? See, logically you can see that the meeting will happen somewhere between 3:15 and 3:20, because at 3 the hour hand is at 3. By the time 4 happens, the hour hand has gone from 3 to 4. During that time the minute hand would have crossed the hour hand, right? I know it's a very bad attempt at trying to show you what is happening, but yeah. So 3 o'clock, the hour hand is at 3, and before it reaches 4, the minute hand has crossed that. So the meeting has to happen between 3:15 and 3:20. If it was after 4 o'clock, the meeting would happen between 4:20 and 4:25, right? Exactly when will it happen? You look at the starting angle and divide it by the relative speed. So at 3 o'clock the angle is 90, divide that by 11 by 2. 16, 4 by 11. So 3, 16, 4 by 11 is where the meeting happens. What happens after 4 o'clock? At 4 o'clock, the angle is 4 divisions, each division 30 is 120 degree. So 120 upon 11 by 2. (421) 9 by 11 will be the exact time, right? This concept again can be taken further. For example, in the first question, angle between hands, that is pretty much what can be asked. Change of angles can be taken further where a different angle is formed, but again, as far as CUET is concerned, this should be good enough, right? Then is number of times an angle is formed. Number of times an angle is formed. So how many times in 12 hours do the minute hand and the hour hand form an angle of, say, 0 degree? Now, if you start from 1 o'clock, there will be a 0 degree till the time becomes 2. Then again there will be a 0 degree till the time becomes 3. Then again there will be a 0 degree till the time becomes 4. So every hour there is 1 0 degree that is formed. But after 11 o'clock, what happens is, the hour hand and the minute hand will meet exactly at 12 and they will not meet after that, right? So from 11 to 1, there is only one meeting. For every other hour, there is one meeting. Therefore, the angle of 0 degree in 12 hours is formed 11 times. Similarly, this can be remembered that 90 degree will be formed 22 times and 180 degree will be formed 11 times in 12 hours. Every 12 hours, the pattern will keep on repeating. 90 degree, why 22 times? Because 90 degree is formed twice in an hour. Once, for example, here, and second time here, right? So from 1 and 2. The ones at 3 and 9 will be double counted, so I am removing that. So 0 becomes 12 into 1 minus 1, 90 becomes 12 into 2 minus 2, and so on. Next is water image, mirror image. Again, closer to visual reasoning, but suppose I say that in a normal clock, the time is say 8:40, 8:20, 8:20. What will be the time that you can see in the mirror image? What will be the time that you can see in the water image? Now, in a lot of detective novels, Sherlock Holmes and all of those, the mirror image has always been used somewhere or the other in some case. The detective will realize that the watch is actually the mirror image and therefore the murder happened at some other time. What is the mirror image? The mirror image happens across the y-axis. So you have to flip this over for the mirror image. How do you flip it over? If you are flipping the clock to about the y-axis, basically you will turn it on the axis of the line that joins 12 and 6. So you draw your clock on the left side. Anything on the right of the axis goes to the left, anything on the left goes to the right. So the minute hand is 2 positions above the axis. Therefore, the minute hand will be on the right, 2 positions above the axis. The hour hand is 2.5 positions above. So here it will be 2.5 on the left. This is 4, this is 8. So the mirror image time will be showing as 3:40. Right? In case of the mirror image, what you can also do is subtract from 12. So if you subtract 8:20 from 12, the time that you will get is 3:40. What happens with the water image? Water image gets inverted across the x-axis. This has to be flipped here, the reflection in the water. And therefore, how will you turn the clock? Now you will take the 3:9 line and turn the clock about that line. anything below goes above, anything above goes below, right? So the hour hand is just below the axis, so it will be just above the axis. The minute hand is one division below the axis, it will be one division above the axis. So this becomes 9, 8, this is 2, sorry, this is 9, this is 8, this is 10, this is 2, this is 3. So the time becomes 9, 10. Right? The water image and the mirror image. Last topic in clocks would be faulty clocks. Again, I think a little beyond the scope of what we are looking at for CUET, but typically it will say a faulty clock gains 2 minutes every hour, right? How much time will it gain in 20 minutes, say 10 hours. So when I say a clock gains 2 minutes every hour, what I am saying is, if the faulty clock and the actual clock are set right at 12 o'clock, the faulty clock will be 2 minutes ahead every hour. So when the actual clock shows time as 1 o'clock, the faulty clock will show 1, 2. When the actual clock shows 2, the faulty clock will show 2, 4 and so on. Right? That is how the faulty clock will work. The faulty clock would be running ahead or behind time. Also, every faulty clock will show the correct time. Right? So any one who has watched old Hindi movies would know that बंद घड़ी भी दिन में 2 बार सही समय दिखाती है, right? Because analog clocks do not have the concept of AMs and PMs. Every time a faulty clock is 12 hours or 720 minutes ahead of the normal clock or 720 minutes behind the normal clock, they will be showing the same time. Of course, in the real clock it might be 5 AM, in the faulty clock it might be 5 PM, but they will be showing the same time, right? That should suffice for the purpose of this exam. Just quickly looking at a couple of questions. What is the angle made by the minute hand and the hour hand at 4:40? (4:40) in the minute hand is exactly at 8. The hour hand is between 4 and 5. So 1, 2, 3, 4. 4 into 30, 120. Since I am going from the minute to the hour hand in anti-clockwise direction, so minus what? 40 into half, which is 20. So an angle of 100 degrees. Or 30 into 4 minus 11 by 2 into 40. Sorry. This is 120 minus 220. Therefore, mod of minus 100. 100 becomes the answer. Right? How many times in a day are the minute and hour hand of a clock in a straight line? So a day means 24 hours. And straight line means they could be overlapping one above the other, or they could be in opposite directions. Right? 0 degree is formed 11 times in 12 hours. So in 24 hours, this will happen 22 times. 180 degrees formed 11 times in 12 hours. So in 24 hours, this will also happen 22 times. Hence a total of 44. Just be a little cautious in what is asked in this type of a question, because conceptually they are not very heavy, and even the angle that is asked will be repeated. What would be played along is the duration of time that is asked for, or for example here I have clubbed 0 and 180 degrees, something like that would happen. Just read the statement carefully and you will be able to answer basis what we've just covered. Right? Then is inequalities. Inequalities typically is a common question in a lot of government examinations, right? It was also there in some of the school examinations that have happened for other colleges and universities. So just touching upon it, typically the question will look something like this. There would be a statement, information given, and then there will be two conclusions. You have to you have to find out whether the given conclusions follow from the statements or not. Assuming values here may be a good option, but there is a possibility of you getting the wrong value, or you end up assuming close values, which creates a problem. So a good idea is just make a relative position chart. For example, the statement say A is less than B. This is less than, this is greater than, less than or equal to, greater than or equal to. So A is less than B means B will be higher, A will be a smaller value. Then I look at any information given about A and B. It is given that A is equal to D. So A and D will be in the same range, same plane, so to say. Next, C is greater than equal to D, D is greater than E. Therefore, D will be below E for sure. C could be equal to D, or C could be above D. Now, as the moment you go above D, C could either be more than B, equal to B, or less than B. All three possibilities are there. So I look at the conclusion. C is greater than B. May happen, may not happen. So 1 does not obviously follow. It may or may not happen. B is greater than E. That will definitely happen, and therefore in question 13 only conclusion 2 definitely follows and therefore is correct. 1 may or may not be correct. Right? Look at the next question then. P is equal to Q is greater than equal to R is less than S is greater than equal to T. Two conclusions are given. R is less than P, R is equal to P. This is actually a lot easier. P is equal to Q, so they are equal. Q is greater than equal to R, so Q could be greater than R. Q higher, R lower, or I could have this kind of a situation where Q is equal to R. R is less than S, therefore S will also be, R is less than S, so S will be above R for sure. And S is greater than equal to T, so T would be equal to or less than S. I am not getting into drawing all the cases because the conclusions talk about R and P only. Is R less than P? R here is less than P, but here R is equal to P. So 1 is not always correct. Is R equal to P? Again, 2 is not always correct. Right? But with respect to R and P, only these two cases are possible. Either R will be less than P or R will be equal to P. And therefore, the answer becomes either 1 or 2 is correct. Either the first one will be correct. If that is not correct, the second one has to be correct. And vice versa. Right? A lot of the exams repeatedly ask questions on visual reasoning. So I just listed some of the types of questions that you can expect. One is a Venn diagram based problem. Typically here you're just spotting the numbers and finding the answers. For example, it says in the given diagram the rectangle represents doctors. So these are doctors. The circle is engineers, doctor, engineer, and the triangle is male. Any area that overlaps becomes someone who is both of them. Then there are numbers mentioned: 38, 47, 84, 69, 45, 29, 74. You just have to find out each type of. For example, how many males are engineers and doctors? So male was the triangle, that value has to be in the triangle, plus it has to be in the circle and the rectangle as well. So what is the common area? This is the triangle that is common to, actually this is the part of the triangle that is common to the rectangle or the circle. And if I look at this part here, this is common to the circle, the rectangle, and the triangle. Therefore, these people will be males, doctors, and engineers. So the answer simply becomes 69. That is the value written outrightly. Next, how many doctors? Doctors were the rectangle. So we are looking at the rectangular part. Are males but not engineers. Engineers are the circle. So first of all, I remove the circular part because I don't want the engineers. Right? So I am left with these two values. These will be the people who are not males. These will be the people who are males. So how many doctors are males but not engineers? This becomes the answer, which is written as 45. Straightforward, just look at the question, find the value and answer. How many people are not doctors? Doctors versus rectangle. So just remove the entire rectangle part. I am left with these three values. 74 plus 84 plus 29. 8, 9, 17, 7, 1, 8, 15, 16, 17, 18. If you do come across a question like this, definitely something that should be attempted, because again I am doing it on the screen. I just mark it on the screen. If you are doing it on paper, the rough work, and there are 2 or 3 questions, it may not be a bad idea. Just draw very briefly the diagram on the paper and mark what is the doctor, what is the engineer, what is the male. Don't need to write numbers. According to the question, just see which area you are looking at and plot the numbers for that area from the screen. That is how you will go about the question while you are sitting and giving a mock or the actual exam. Then Venn diagrams are used in case of the mix of visual reasoning and logical reasoning, where there is there are objects given and you have to find out which Venn diagram shows the relationship for these things best. For example, which of the following best captures the relationship between animal, horse and cat? Both horse and cat are animals. So horses and cats will be a part of the group animals. Also, horses and cats hopefully do not have anything in common. So which diagram best represents that kind of a relationship? Obviously, these circles are not completely inside any. Every horse is an animal, every cat is an animal. If this becomes animal, this is horse, this is cat, that best captures the relationship. All horses and cats are part of the animal kingdom, but they have nothing in common, and therefore, right? What if the relationship is asked between alloys, steel and helium? Helium is a gas, I think. Very bad at chemistry and physics and maths and SST and science. Yeah. So alloys essentially are mixtures of metals, probably, and steel I know is not a metal per se, but carbon mixed with iron is steel, right? So steel is an alloy, helium is a gas. So if I look at alloys, steel will be a part of alloys, a type of alloy. There can be other alloys as well which are not steel. Where will helium be placed? Helium is not an alloy, therefore it has to be outside this part which talks of alloys, so outside that circle, and therefore the relationship is best captured by option 3, visual reasoning. Some questions talk about the different figures that are formed. For example, how many triangles are formed in this star? A good idea always is to start from the smallest part and build bigger. For example, here there will be 5 small triangles. I mean, this should have looked more symmetrical, and then I'll combine to form other triangles. For example, one of them will be this one. One of them will be this one. One of them would be, sorry, this one. One of them would be this one, and so on. So basically 5 triangles at the points of intersection. So the answer becomes 10. Let's see, if the figure is symmetrical on all sides, you can also use combination here. How many lines are there in this diagram? It's a 5-pointed star, so there are 5 lines. 1, 2, 3, 4, 5. All of them meet the other lines similarly. The points of intersection are same for each of the line. So the figure is symmetrical. So what I can also do in this case is, for a triangle I need 3 lines, and therefore I can say out of 5 lines, if I choose 3, permutation combination, I'll still get the answer as 10. I understand it will not work out every single time, but if it is a completely symmetrical figure, you can do something like this, right? For this question, the answer becomes 10. Oh, how many squares are there on a chessboard? So a chessboard, 64, right? Please don't mind my lines which are not parallel. Something like this, where all lines are equally spaced. Apna chessboard thoda kharab hai. So how many squares are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 64. But there are other squares as well. If I combine these 4, I will get 1 square. Then the next 4. 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 And then the next 4. Now start looking for patterns now. So when I'm making a 2 by 2 square, how many squares are there in the horizontal? 1, 2, 3, 4, 5, 6, 7. 7 in the horizontal. Similarly, there will be 7 in the vertical. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 by 7 will be 49. Next, I take a square which is 3 by 3. How many squares now? 1, 2, 3, 4, 5, 6. Basically, if these lines are 1, 2, 3, for 3 by 3, I'll take 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 6, 7, 8. So 6 in the horizontal, 6 in the vertical. Is there a pattern forming? 64 smaller cubes, 49 larger cubes, 36 further larger cubes, and so on. This is 8 square, 7 square, 6 square. So I complete the pattern: 5 square, 4 square, 3 square, 2 square, 1 square. So 1 will be this entire big box, which will be a square in itself. 1, 2, 3, 4, 5, 6, 7, 8. Add them to get the answer. 64 and 36 is 100. 25 and 16 is 41. 41 plus 49 is a 90. 9 plus 1 is 10. And then there is a 4. Therefore, the answer becomes 20. If you remember the formula for the sum of squares of the first n natural numbers, that is also something that you can use. Basically, the sum of the first n natural numbers, 1 plus 2 plus 3 plus 4 up till n, is given by n into n plus 1 by 2. The sum of the first n squares, 1 square plus 2 square plus 3 square plus 4 square up to n square, is given by n into n plus 1 into 2n plus 1 by 6. And sum of the first n cubes, 1 cube plus 2 cube plus 3 cube, is given by n into n plus 1 by 2 square. If you know it, excellent. If you don't, not a problem. I definitely do not see it going to this point. At most, this is something that you might end up using. Right? Then there are these kind of questions. These are questions that I, again, very expected in the examination. So what happens is, there are 4 problem figures. There are 2 broad types. The first type will talk about 4 problem figures, and there will be 4 options. You have to choose that option which will continue the pattern of the problem figures. Okay. So here 3 broad things could be happening. The first thing that you do is you identify the elements in the first figure. From there you see whether there is an increase in elements. Number 2, whether there is a change in orientation. Number 3, change in position. Number 4, change in color. Right. So for example, in these problem figures, as you can see, There are just two objects across the grid, across the x and y axis. Their orientation also does not change because one is a circle, one is a square sort of a thing. Their positions are changing, right? So just see how the positions change. For example, if I look at the circle and I say that these are quadrants 1, 2, 3, 4. Circle goes from 1 to 2, then 2 to 3, then 3 to 4. So basically what the circle is doing is, it is going in the anti-clockwise direction, one quadrant at a time. What happens with the square? Again goes from 2 to 3, then from 3 to 4, 3 to 4, then 4 to 1. The circle is also going in the same direction, one quadrant at a time. And therefore, it would make more sense. So if I want to continue the pattern, I will change one, I will make the same change again. So the square will go into the second quadrant and the circle will come in the first quadrant. From the options, option 4 satisfies, right? Another question, for example, this is an analogy question. So here, these two figures are related in some manner. You have to find one of the fourth figure, one from the options, which are related, so that these two images are related just like the first two. Now what is the relation in the first two images? There is a triangle, there is a square in the first image. The same figures are there in the second image as well. The only thing is, the triangle was outside, it has gone inside. The square was inside, it has come outside, right? So their relative size changes. Also, the triangle is pointing up, now it points downwards. The square also has taken a turn by 45 degrees. So first it was in diamond shaped, now it is back in the square shape. So these are the changes that I have to do. So if I am looking at these, if I am looking for a similar figure with the same relationship as 1 and 2 for the fourth one, first of all the pentagon will go outside, the 5-sided figure and the square will come inside. Also, the triangle had changed shapes. The square had just moved by 45 degree, half a rotation. And therefore, from the options, one figure got inverted, one just turned a little bit. So if I think like that, the square, which is not the pointing figure, which is symmetrical, gets turned by 45 degree. So I'll turn the square inside, make it flat. The pentagon, which is a pointed figure, has to invert, and since it is inside, it will come outside. So something like this might happen. Sorry, the pentagon. And therefore, from the options, D looks to satisfy the given relationship. So the pointy figure, the figure pointing in one direction has to reverse, the figure outside goes to the inside, and the square just turns by 45 degrees, right? Then the next type of question is data sufficiency question. For data sufficiency, essentially again data sufficiency is just a type of question. The concepts used can be from any topic. So what essentially this asks you is, there will be a question and there will be statements given to you. You have to find out which statements are sufficient to answer the question, and therefore you look at options like this. So the question is, in a race amongst 4 people A, B, C and D, who finished last, right? I am not looking at their positions, I just want to know who is the person who finished last. What you do is, you choose first, try to answer the question using statement 1 alone, then you answer the question using statement 2 alone. If either of them works, this could be the option. If that does not work, you combine both 1 and 2 and try to, in that case this would be the answer. If you are getting answers from both 1 and 2 individually, then option 1 becomes the answer, otherwise 4 is the answer. Okay, so let us try and do that. In a race amongst 4 people A, B, C and D, who finished last? Statement 1 says D was second to only one person. So according to statement 1, 1, 2, 3, 4, D would have been second to only one person, and exactly one person finished between C and D. Now if there is one person who has to finish between C and D, C cannot be in front of D because there is just one person ahead of D. C has to be behind D. Now I do not know where A and B are, but basis this statement I can find out who finished last. C finished last. So the question can be answered using statement 1 alone. Let's look at 2 as well. Only one person finished after D. 1, 2, 3, 4. Now D, according to the second statement, D would be third, and A and B finish the race one after the other. So A and B have to be together, cannot be after D because there is only one position. So A and B would have finished at 1 and 2. I do not know who is first, who is second, but they would be one after the other. And therefore, who has to be last? Since A, B, D are done, C would be last. And therefore, using statement 2 also alone, I can answer the question. The answers may be different, does not matter, but the question can be answered, and therefore, the answer to the question 24 would be either 1 or 2 is sufficient. You could use 1, get the answer, you could use 2, get the answer. It will not be both. The answer is both when you have to combine both the options to get one answer, right? So that is the difference between either and both. Another question, for example, the question is x raised to power y greater than y raised to power x? X raised to power y greater than y raised to power x, is it so or not? Statement 1 says x is greater than y. So I can, for example, assume values. I say let x is equal to 4, y is equal to 3. Is x raised to power y greater than y raised to power x? 4 raised to power 3 is 64. 3 raised to power 4 is 81. 64 is not greater than 81. So in this case, the answer is no. What if I took some other values? For example, suppose if I took x as 3 and y as 2. So x raised to 3 square, 2 cube, 9 is greater than 8. Then the answer would have been yes. So using statement 1, both the things can happen. It could be greater, it could be not be greater. The answer would be yes or no. So statement 1 is not sufficient to answer the question. Statement 2 says x is greater than 0, y is greater than 0. Now using alone that statement alone, if I know that x and y are two numbers greater than 0, again many cases are possible. If I combine them, I still don't have a definite answer, and therefore neither 1 nor 2 is sufficient to answer the question. Data sufficiency, right? So broadly, these are the topics that you can expect in the logical reasoning section for the general test for CUET exam. Also, there are topics like syllogisms, data consistency, critical reasoning that will be covered in another lecture or in another video, right? So thank you very much. All the best. Keep practicing.